Hello everyone. Today's topic is Introduction to C language. So first, what is a programming language? A programming language is a set of instructions through which humans interact with computers. Programming languages are the tools we use to write instructions for computers to follow. Computers think in binary, that is strings of ones and zeros. Programming languages allow us to translate the ones and zeros into something that humans can understand and write. A programming language is made up of a series of symbols that serves as a bridge that allow humans to translate our thoughts into instruction then computer can understand. So programming languages fall into two different classifications. First one is low level language and second one is high level language. So here first one is low level programming languages are closer to machine code or binary, so therefore they are more difficult for humans to read, although they are still easier to understand than ones and zeros. The benefit of low level language is that they are fast and offer precise control over how the computer will function. So next one is high level programming languages. So here, so they are closer to how humans communicate. High level languages use words like object, order, run, class, request, etc. that are closer to the words we use in our everyday lives. So this means they are easier to program in than low level programming languages, although they do take more time to translate into machine code for the computer. So let's see the differences between high level and low level programming language. So here the first difference is low level programming language is a programming language that provides little or no abstraction from a computer's instruction set architecture. So here in high level programming language is a programming language with strong abstraction from the details of the computer. The second difference is in low level programming language it is difficult to learn and use. So whereas high level programming language it is easy to learn and use. Next, in low level programming language, this programming language is machine dependent, whereas high level language it is not machine dependent. So in low level language it does not provide the feature of inbuilt functions. In high level language it provides features of many built-in functions. In low level language program execution is fast. In high level language program execution is slow. So in low level languages can be converted to machine code without using a compiler or interpreter, and the resulting code runs directly on the processor. High level languages can be converted to machine code using a compiler or interpreter. Next, in low level language it is very difficult to trace errors in low level languages. So in high level programming language error tracing is easy as compared to low level languages. Next, let's see the difference between high level language, middle level language and low level language. So in a high level language, high level languages provide almost everything that the programmer might need to do as early built into the language. So in the middle level languages don't provide all the built-in functions found in high level languages, but provides all building blocks that we need to produce the result we want. So here low level languages. Low level languages provides nothing other than access to the machine's basic instruction set. So here the example for the high level language is Java, Python, and in middle level we have C, C++ are the examples. In low level language, assembler is the example of the low level language. So history of C language. C evolved from two previous languages, BCPL and B. Here BCPL stands for Basic Combined Programming Language. So BCPL developed in 1967 by Martin Richards as a language for writing OSS and compilers. So next, Ken Thompson modeled many features in his language B after their counterparts in BCPL and used B to create an early versions of Unix operating system at Bell Laboratories in 1970 on a decimal PDP-7 computer. So both BCPL and B were typeless languages. The only data type is machine word, and access to other kinds of objects is by special operators or function calls. The C language developed from B by Dennis Ritchie at Bell Laboratories and was originally implemented on a DEC PDP-11 computer in 1972. It was named C for new language, that is after B. Initially, C used widely as the development language of the Unix operating system. Today, almost all new major operating systems are written in C, including Windows. So let's see the importance of C language. The C language is small and relatively easy to learn. C compilers can produce highly efficient code. It is robust language which has a rich setup of built-in functions and operators. So they can be used to write any complex program. So program written in C are efficient due to several variety of data types and powerful operators. The C compiler combines the capabilities of an assembly language with the feature of high-level language. Therefore, it is well suited for writing both system software and business package. There are only 32 keywords. Several standard functions are available which can be used for developing program. C is portable language. This means that C programs written for one computer system can be run on another system with little or no modification. C language is well suited for structured programming. This requires user to think of problems in terms of functions or modules or block. A collection of these modules make a program debugging and testing easier. C language has its ability to extend itself. A C program is basically a collection of functions that are supported by the C library. We can continuously add our own functions to the library with the availability of the large number of functions. C has been used to implement in whole or in part several major operating systems and kernels including Unix, Linux, Mac OS and Windows. So next, what is a compiler and what is assembler? Assembler. Here the compiler is used to translate an high level programming language code to machine level code and to create an executable program. Here compiler checks the errors in the program and reports them. All errors are to be removed, otherwise code will not be compiled and executed. So here compiler translates the programming high level programming language code into machine level language code. So here assembler, next one is assembler. Assembler is used to translate an assembly level code to machine readable code. So assembler to checks the correctness of each instruction and reports the diagnosis report. Let's see the differences between a compiler and a assembler. So here, so one side is key and next one is compiler and another one is assembler. So first one is operation. So compiler translates high level programming language code to machine level code. So here assembler converts the assembly level language to machine level code. So here input, next one is input. So here source code in high level programming language. So we use in source code we use high level programming language. So where in assembler we use assembly level code as input. So third one is conversion type. So here compiler checks and converts the complete code at one time. So whereas assembler generally does not convert complete code at one time. So fourth difference is components. So here in compiler we use lexical analyzer, syntax analyzer, semantic analyzer, code optimizer, code generator and error handlers. These are the components in compiler. So in assembler does works in two passes. So fifth one is output. So here we use mnemonic version of machine code. In compilers we use mnemonic version of machine code. So in assembler we use binary version of machine code. So here are the examples of compiler: C, C++, Java compilers. So in assemblers, GAS and GNU assemblers. These are the two examples of the assemblers. So in compiler we have C, C++, Java compilers. So next one is structure of C program. So this is the structure of C program. So in the structure, first we have documentation section, after that we have link section, and then definition section, after that global declaration section, and after that main function. So and opening curly braces and ending curly braces. In between we have declaration part and executable part. So after main function we have subprogram section, that means user defined functions. Here we can declare as many as user declared functions. So function 1, function 2, like that up to function n. We can declare many functions as per our requirements. So now see, the first one is in the structure of a C program. The first one is documentation section. So here the documentation section consists of set of comment lines. So these comment lines gives name of the program, name of the author and other details which the programmer would like to use later. So here the syntax. In the syntax we have two types of comment lines. So first one is multi comment lines. So here multiple comment lines starts with a slash, star and comments must end with star and slash. Okay, so we have two types of comment lines. First one is multiple comment lines, second one is single line comment. So here first multiple line comment lines starts with slash, star, next comments, and after that star slash. The second one is single line comment lines, that is double slash. Okay, so here example. So now I'm writing a single, I mean multiple line comment. So first, we know that multiple line comments always starts with slash, after that star. So now we have to write the comment. So I'm writing this comment: C program to find GCD and LCM of two numbers using Euclid's algorithm. So this is the comment. So now this comment must end with star and slash. Okay, and next one, single line comment. So we use double slash, after that we have to write the welcome to C. This is the comment. Okay, and this is the difference between single line and multiple line. Next one is link section. So the link section provides instruction to the compiler to link functions from system library. So here the syntax: hash include header file name dot h. So this is the syntax: hash include less than symbol, header file name dot h, and greater than symbol. So here in this header files we have different types of header files. In that, first one is stdio, that means standard input output. Next one is conio, so that means console input output. Next one is math, so this function contains mathematical functions like cos, sine, square root, absolute, like that. So for this we have a next examples. So here I have given two examples, that is first hash include stdio dot h, hash include conio dot h. So here include, so here including a header file to our program. So here stdio dot h is the header file. This file is this header file is linked to the our program. Next one is definition section. This section is used to define symbolic constants. So in the definition section we define symbolic constants. So here is the syntax. So first, hash define symbolic name space constant value. So see this: hash define space symbolic name space constant value. So this is the syntax. So let's see the examples here. Hash define space pi space 3.142. so here we are defining a constant variable, that is pi, and I'm assigning a value, it 3.142. this is the value of pi. So now I have declared a constant value, defining constant value. Next, second one is hash define max marks space 100. So now I'm declaring a max marks with assigned a value 100. The next, third one is hash define space min marks space 35. So here min marks is the constant name, symbolic name, and here 35 is the constant value. Okay. Next one is global declaration section. Next, main function section. Next one is user defined function. So here first, global declaration section. So it is used to define those variables that are used globally within the entire program and used in more than one function. This section also declares all the user defined functions. So once we declare the global declaration section, so in this global declaration we use variable declarations. So once we declare in global declaration section, they are used in entire program. So here that means these variables are used by one or more functions. Okay, that means more than one function. So that means these variables are accessed by main function and also user defined functions. So next then comes the next one is main function. Here all C programs must have a main function. So main function contains two parts. First function part, second one is execution part. So the declaration part is used to declare all variables that will be used within the program. There needs to be at least one statement in the executable parts, and these two parts are declared within the opening and closing the curly braces of the main function. Okay, main function contains opening curly braces and closing curly braces. In these braces we have to declare the variables, and we have to write the statements and execution parts. So the execution of the program begins at the opening brace, that is curly brace, and ends with the closing brace, that is closing curly brace. So and also it has to be noted that all the statements of these two parts need to be terminated with a semicolon. And that means in C programming, every statement must end with a semicolon. So here semicolon indicates the end of the line, end of the statement, semicolon here indicates that it is the end of the statement. So next last one is subprogram section. So it is also called as a user defined functions. So these user defined functions are called from the main functions. These user defined functions are declared and usually defined after the main functions. Okay, so C function. So C programs always the C program execution starts from main function. So here C program must contain one main function. So user defined functions are 0 or more. Okay, right. Next, steps involved in executing C programming. So first we have to type the program in C editor and then save with .c extension. To save the C program, we have to press F2 key on the keyboard. Okay, now a save as dialog box appears. After that we have to write the file name with .c extension, and then after that click on save button. Next, after saving the file, we have to compile the program. So to compile the program, press Alt plus F9. So whenever we press Alt plus F9, now the compiler compiles the program. So next, the compiler checks for the errors. If there are errors, then it will show the errors. After that we have to correct the errors, and then we have to recompile the program. Again we have to compile the program for the errors. Okay, next, if there are no errors, then press Ctrl plus F9 to execute or run the program. So if there are no errors, after that we have to run or execute the program. So here the key is Ctrl plus F9 to execute the C program. So now if you wanted to see the output or check the result or user screen, press Alt plus F5. Okay, press Alt plus F5 to open user screen and check the results. So these are the steps involved in executing C program. So this is very important. Once again I'm telling you, first we have to write the C program in a C editor, and after that we have to save it with .c function. So to save the C program, what is the shortcut key here? F2. F2 is the function key. Okay, next one. So after saving the file, now we have to compile the program to check the errors. So for this we have to press Alt plus F9. Whenever you press Alt plus F9, it shows the errors. If there are errors, it will show the errors. So now, so errors showed with line numbers. So now the user has to go to the particular line and correct the error, and after that recompile the program. So if there are no errors, then press Ctrl plus F9. So here Ctrl plus F9 means we are executing the C programming. Okay, after that, if you wanted to see the result or check the user screen, so here user screen is nothing but output screen. So press Alt plus F5. So now you will see the result. These are the steps involved in executing C program. Okay, thank you for